Next exercise, exercise number 2. Static stress analysis of a one-dimensional simply supported beam. So what is beam? Beam means the load act perpendicular to the axis, then that element is known as beam. And simply supported beam means here the both ends are supported, is known as simply supported beam. So aim to determine the maximum deflection, maximum bending moment and the bending moment diagram of a simply supported beam subjected to static point load and uniform distributed load. Here the static point load is 1000 Newton and the uniform distributed load. The load is uniformly distributed 50 Newton per mm. The various dimensions are given. First here we go to draw this model. So in the FEMAP software, the first step is step 1, create the node. So model node. So first we fix the origin x equal to 0, y equal to 0, then click OK. And next x equal to 10, y equal to 0. So x equal to 10, y equal to 0, then click OK. And third one, x equal to 10 plus 40, this point, 10 plus 40, 50, 50 comma 0. So x equal to 50 comma 0, that is 50 comma 0 means x equal to 50, y equal to 0. Is it always equal to 0? Then click OK. Then the next ID, this point, 10 plus 40, 50, 50 plus 30, 80. So x equal to 80, y equal to 0 and z equal to 0. So x equal to 80, y equal to 0, z equal to 0, then click OK. Finally, 10 plus 40, 50, 50 plus 30, 80, 80 plus 20, 100. 100 comma 0. And that is x equal to 100, y equal to 0, z equal to 0. So x equal to 100, y equal to 0, z equal to 0. Then click OK, cancel. Then next, select the material selection, model, material, load. Here I choose AISI 4340 steel, then click OK. Then click OK, cancel. The next one, assigning property. So that is model, property. In the material draw box, select AISI 4340 steel, then select element property type. Here choose beam element, then click OK and select shape. So in the shape draw box, select rectangular bar. So here the cross section is 10 mm into 10 mm. So height equal to 10 and width equal to 10. So height equal to 10 and width equal to 10. Then click OK. Then click OK, cancel. Then next create element. So model element. So in the property drop box, select beam property. Then next select vector. So in the vector, fix if y equal to 1, then click OK. Then in the nodal cursor in the box, the cursor is kept in the nodal box. Then select the element 1 and element 2, then click OK. Similarly, in the element 2, then element 3, so it is displayed element 2 and 3. Okay, by using cursor, then click OK. By using cursor, if select in node 3 and node 4, not element 1. This is node 1 and node 2, then node 2 and node 3, then node 3 and 4. So it is displayed node 3 and 4. Then click OK. Then similarly node 4 and node 5. Then click OK. So all elements are selected. So finally cancel. Next one, apply boundary conditions. So here the both ends are simply supported. So we use model constrained model. Okay. So select simply this title page by click OK. Then select this leftmost corner node and rightmost corner node. So make sure this is +1 and +5. Then click OK. Then here simply supported. So translation in x-axis, translation in y-axis. So here tick Tx, Ty and Tz and Rx and Rz. Make sure only Ry only untick. Okay, then click OK. Okay, then cancel. Now next here we go to apply the load. So model load model. So first here we go to okay model. Then simply skip this one by skip the title page by click OK and select the node 4. Okay, make sure this is node 4. Then click OK. Then select the force parameter. So make sure is in the force. So in the downward direction of y-axis, right? So this point load, this one is act in the downward direction. That is 1000 Newton at node 4. So minus 1000. Okay, Fy minus 1000 minus 1000 minus 1000, then click OK, then click OK, okay, then cancel. Similarly here we go to draw the uniform distribution load. Okay, uniform distribution load. So model load elemental, model load element, and select the second element, then click OK, and the distribution load, distributor load at load end A equal to, so 15, the value is 15, right? The value is, so it acts in the downward direction in the y-axis, so minus 15. Okay, minus 15. So here end A is minus 15 and load end B is minus 15. Okay, minus 15, then click OK. Okay, then here you don't bother about the direction, simply click OK and cancel. Okay, so this one here, this side is end A and this side is end B. Okay, now so analysis, next step is analysis. Model analysis new, and make sure analysis type is static, then click OK, then analyze and wait some times for load result. So the here the software analyze the entire procedures, so the load result is displayed. So make sure there is no error, there is no warning message. So then simply we select click continue, and now we view the results. So view, select, and deform style as deform and contour style as none, and deform and contour data. Here the deform is total translation, then click OK, then OK. This is the first result. Now we go to view the beam diagram. So view, select, view, select, deform style as none, and contour style as beam diagram, and deform and contour data. In the contour draw box, beam NDA plane 1 moment. So memorize this, I mean this number 3014 is the identification number. Beam NDA plane 1 moment, select it, then click OK, then OK. So this is the required result. Okay, this is the required result. This is the beam diagram. Okay, thank you.